This video covers colorimetry and solution making, where we will examine the principles and variables involved with colorimetry. For exploration 1, you will observe the colors of salts and their corresponding solutions, which are just those salts dissolved in water to make the solution. Record the colors of each on page 125.
Ultimate goal for the day is to identify the concentration of sample 11, 22, 33, and 44. And now we have 8 substances, all right, and 8 solutions corresponding to those 8 substances in front of you. For barium chloride, most of students will say clear. Now clear is a transparency. Clear is not a color. What is the color?
For barium chloride, the salt is reported as white in color, while the solution is reported as clear, colorless.
Nomenclature is going to be on your final, so make sure, because it's a transition metal, and then you have to have the Roman numeral and then that 2, all right? It's a cobalt 2 chloride. And the color of the solution, pink. Chloride solution, without any comparison, you will say, that is colorless. However, we will have the true colorless, which we have introduced to all of you just a few minutes ago, and then barium. Side by side with our manganese 2 chloride, then you will see, that's actually very, very faint pink, okay? Chromium 3 nitrate. Oh, is this nitrate? All right, nitrate. All right. When you look at the solid, that is very, very dark. However, if you look at the solution, and then you will see, okay, that is the true violet. Make sure you understand the violet, it's not purple, okay? And then it's a violet. It's a violet blue. All right, iron 3 nitrate. You look at and the color of the solution, it's yellow. All right, now make sure you understand the color of the solid. That looks like orange yellow or yellow orange. All right, it is orange yellow, so the color is yellow. All right, even though it's rather dark. All right, now copper 2 chloride. Color of the solution, blue. And then color of the solid, it's greenish blue, so it's still blue. Nickel 2 sulfate. Color of the solution, green. And the color of the solid, well, that is bluish green. So the color is green. So make sure you understand how we describe the colors.
Once you have recorded the colors of both salts and the solutions, pay attention to where these metal ions appear on the periodic table. Which metal ions give you colored solutions and which ones are white or colorless in appearance. For exploration 2, you are being shown 6 bottles containing copper 2 ions and chromium 3 ions. You have to decide whether all of the solutions are of same color or different colors. On observing closely, we notice that there are indeed two colors present. The blue color appears from the copper-2 ions, whereas the violet color appears from the chromium-3 ions. The only difference is the difference in intensity of these color solutions. For step 4 of the exploration 2, note any changes that appear in the solution when the stoppered flask is inverted. Before the inversion, observe how dark the solution appears, and observe after the inversion how light that color intensity has become.
For each substance, there is a color associated with it. So now chromium 3. So there is only one color. So all of you agree, all right? One color. But the intensity cost, darkness or lightness, it's because the concentration. Do you all think the concentration right here it's more higher than the concentration right here? Obviously not, because it's all uniformly distributed. So what is the cause of this? All right, so the distance light travel past this distance, all right? And light travel past this distance. It's what we call the path length. All right? Right here you can see the path length, it's much shorter, smaller than here.
The Beer's law explains the difference in color in the same apparatus. For exploration 3, we will be making a solution of given conditions starting from a pure material.
It's a 50.00 milliliter. See, here it's a liter, here it's a milliliter. We can operate on this. So we needed to either convert a milliliter to liter or liter to milliliter. Most of them are told to convert a smaller one, which is good. I mean, I don't really care. And then make sure all of you needed to take your units all in. So now you see you can cancel, you can cancel, you can cancel, you can cancel.
We need to convert the moles into grams by using the molecular formula weight for copper sulfate pentahydrate, as we have learnt in the limiting reagents and percent yields experiment on page 68.
249.7 gram per mole. You cancel moles, you cancel moles. Now you have the grams. Sig fig.
Your professor will discuss the 5 steps of the methodology to be used for the solution making. According to exploration 3 and the method discussed therein, you will weigh out exactly 6.24 grams of copper sulfate pentahydrate solid.
6. 2, 4. Okay, that's it.
You will now obtain a 50 ml volumetric flask and make the solution following your procedure from point 6.
Now it's all in.
Using a measuring cylinder, you will add approximately half of the volume that the volumetric flask can accommodate. For example, for this 50 ml volumetric flask, you will be adding approximately 25 ml of deionized water to completely dissolve the solid.
So now it's 10 and another 10 and 5. Okay. Now you're going to follow your method. All right. Keep shaking until all it's dissolved or totally dissolved or completely dissolved. You don't want to see any solid inside of it. So this process is about 5 to 10 minutes, all right? Your agitation must be effective, all right? So just do it. If one person gets tired, the other person takes over, okay? That's all. Okay, now don't make your decision to add any more water just yet, because once when you add too much water and you will fail to. Now you can see there are lots of solids still right there, and then you can't really see. All right, only so. Just takes time, but sooner or later, it's not just soon, it's later, and you will get there. Okay, now you can see actually much less, right? Much less. Only in the center there's still a little more. So going to. All right. So just keep shaking your. This is how you make solutions, and then for most of us, this it's what we do every day for the rest of our life. Okay, very good. All right, you can see almost gone, but still in the middle, you can still see a big green and some others. All right, yeah, we're going to still do it. It's not 5 minutes just yet, you know it, all right? And so your agitation, this agitation must be effective, all right? Gentle like this, it's not going to do anything. You can see how I do it, and this must be effective, and shaking the agitation must be vigorous. I see still 1 or 2 greens moving around, but that's pretty good, all right? While you're doing this, supposedly, your partner, or you have already done this already, all right? Simply take the wax paper off, peel off from the pale film. Don't spend a lot of time, all right? Don't spend a lot of time. So ready to cover it.